Everyone. Berit here with Future in Review. I'm here today with a special conversation for you about our shared climate future. This is an interview that I did recently with bestselling science fiction author Kim Stanley Robinson as a part of our SNS Spark salon. Now, for those of you who haven't yet heard about SNS, we publish the SNS Global Report, which is the world's most accurate source of information about the future of technology as it drives the global economy. It's a weekly deep dive analysis that comes straight to your inbox, and it's where all of us at Future in Review publish our writing. Now, SNS subscribers get together in Spark salons, off the record virtual gatherings where we all have a chance to discuss the news and patterns that we're tracking. And this month, we decided to share a part of that conversation with all of you. We believe that everyone should have an expert guide into our climate future, especially, and potential solutions. And Stan is a world expert in this. I hope you enjoy the conversation, and I'd love to hear your thoughts and feedback in the comments. Until then, enjoy.
My pleasure, Berit. And immediately I want to say thanks to the whole SNS Fire gang. And I see also on the list of participants, the Anderson crew, that whole community includes a lot of my teachers. So I will be reiterating things that some people on this call know better than I do, but happy to do so, and I'll bring what perspective I can.
Wonderful. Well, that's part of the reason that we have these salons, because we bring incredible people together and we get to have really high level conversations. So we are very happy to be here with you today. I want to structure the conversation around a framework that you have put out there, which is pessimism of the intellect, optimism of the will, right? So we all know that we are facing a pretty dire climate emergency globally, and we're not going to sugarcoat that today. We are going to talk very practically about it. But we also want to be very optimistic about what it is that we can do. And because there are a lot of technical solutions out there and social and political solutions, our biggest barrier, as we have talked about many times at FIRE and in SNS, is time, right? So all of these systems are moving very quickly, something that we've covered earlier this year. But so I want to start by talking a little bit about the 2025 Planetary Boundary Report, which just came out a couple of weeks ago. So that report, Stan, concluded that 7 out of 9 planetary boundaries have already been breached. The one in particular that they called attention to was ocean acidification, which is deeply worrying from a wide range of perspectives, including the fact that the ocean is a carbon sink for about 30% of total emissions. Can you tell me a bit more about your thoughts on that report?
Yeah, sure. I like it. This planetary boundaries concept started, I think, although there are people in this call who have been intimately involved with its intellectual formations, like Amory, but it's Johann Rockstrom's paper in Nature in 2009, which he re-upped refreshed in a Nature paper in maybe 2023, that instead of a graph, and so a graph with an X and Y axis can actually be deceptive because you don't know the units for sure on the X and the Y. And the artifact that's created is not exactly, is something that we're used to, and overlook how deceptive it can be in telling us things that are interesting. So putting things in a circle. This was also Kate Raworth with Donut Economics. So there's a combination going on, and I believe they've even collaborated now between Kate Raworth and her Donut Economics and Johann Rockstrom with his planetary boundaries. And this most recent paper in Nature has Kate Raworth as one of the principal authors. And that's nice because her book, Donut Economics, was in the category of what you might call a pop bestseller, popular economics for the nonfiction bestseller list. And as such, wasn't taken as seriously as it might have been at first. And the reason, and of course, the name donut doesn't help, but there's an inner circle as well as an outer circle. So for Rockstrom, the important thing, planetary boundaries, has been the outer circle, Human uses of various parts of the biosphere have an outer limit beyond which we are cutting into the capital rather than disposable income, to put it in economics terms, and wrecking the biosphere in the process in ways that are going to be harder and harder to recover from. That's the outer boundary. For Kate Raworth, the inner boundary was human welfare. How were people doing in terms of health and happiness, and as opposed to suffering and coping with diseases, etc. So uh, the human economy, civilization itself, you might say, ought to circulate in a circle of use, reuse, recycling, and then reuse again within a circular motion in this donut shape. And then the 2009 paper was much more quantitative and concerned with the outer limit, as I say. Now, the new Nature paper includes the inner boundary and tries to discuss human health and welfare on the inside of the donut. So really, the Kate Raworth imagery, the method of graphing, if that's the right way to put it, or representation, has been fully integrated into the scientific model. And Rockstrom, COP30 may designate a chief planetary scientist, which I think is a silly idea and maybe even a bad idea. But if there's already a chief planetary scientist, which is Johann Rockstrom of the Potsdam Institute in Germany. So this paper, which is quite long and detailed, is attempting to replace GDP as a measurement of human welfare in its civilizational aspects, and pointing out that we are crashing through certain planetary boundaries on the outside that are going to be really dangerous going forward. And I want to add right now that we're on a slippery slope. I want to change the image from tipping points to slippery slope. And it's a slope that's getting steeper as we slide down it. We're holding on to it. You could use climber imagery. We got pitons, we got chalks. We're holding on by our fingernails to a slope that's rough and getting steeper. And it's not, what I want to suggest here is the fall is nonlinear. A point could come where we heat the planet up, and this is just to regard one aspect of the overshoot, which is CO2 and methane in the atmosphere. Heat the planet up enough to release all of the locked in and frozen carbon and methane in the Arctic principally, and release as much CO2 and methane as humanity has done since the Industrial Revolution in a not a rush, but in a steady and unstoppable flow, so that we will have increased our problems to a possibly unsolvable degree. So this paper is just one illustration of a more general truth. We're in an overshoot century, and let's just focus on the CO2 because it's so much the driver of the rest. And solving the CO2 problem is the sine qua non. Without this, nothing. We have to, all the other fixes that we might talk about in the rest of this hour are going to be like insufficient, putting band-aids on a cancer victim kind of thing, unless we solve that central problem of reducing our carbon emissions and methane to as near nothing as possible, as quickly as possible. And we will still then be left with an overshoot and a carbon drawdown problem, because the 1.5C limit that the Paris Agreement tried to set civilization to agree to try for, that we've now already reached and broaching through, was not arbitrary. Every 0.1 of a degree Celsius above 1.5 is going to increase the damages to civilization and the biosphere. And right now we're on track to what is estimated to be 2.4 to 3.1 degree rise by the end of the century or shortly thereafter. And that is probably enough, or at least it's because we don't know for sure what would release a runaway greenhouse effect, or when we would make the nonlinear slip into that. But I will say this, that we've got to avoid that runaway greenhouse effect, because we can't stop it once it starts. It's not within human powers to stop that one, even if everybody on Earth agreed to try. It's outside our physical abilities, the same way slowing the rotation of the Earth is outside our physical abilities. So we want to stay on the good side of that particular planetary boundary, and yet we're in an overshoot. So carbon drawdown is going to be something that is going to have to be done. It's going to take decades to do it. And in the meantime, we have to pay attention to all these issues. And like you said, ocean acidification is another thing that is, as we break through that boundary and possibly kill the bottom of the food chain in the oceans, re
I mean,
deacid
it's similar to what you were just saying. It just accelerates the carbon uptake or
yeah.
the CO2.
Well, the CO2, the ocean has got as much CO2 as it can take. It won't get continuously more acidic. It's about maxed out, but that's enough to be very bad. And also it's something that we will have very, very big trouble dealing with ourselves. Actually, de-acidifying the ocean is one of those things that's right on the edge of human ability to do, because we're talking about billions of tons of carbon. And so making it more basic is a matter of dealing with that, simply that much in the way of physical and chemical stuff in the world. It's beyond us. All of these various geoengineering methods that we will continue to discuss in the rest of the hour have to do with leverage points in areas where the things that humans can do might have a significant climate intervention. These are rare and they're going away fast, but they exist, but they're not particularly common.
Yeah, so this is something that you write a lot about in your books. I notice many of your chapters are kind of focused around a specific leverage point when it comes to climate, and you call those out pretty clearly. Let's talk about that as it relates to carbon reduction and drawdown.
Okay.
What do you see as the leverage points there? If that's our most important and most basic problem to solve, where are
Okay.
there leverage points that have not been
I'm
fully
gonna
taken advantage of yet?
Well, I'm not sure there are any, but I'm going to say this also. I bet everybody on this call knows all this stuff, so I'm going to be really quick about it. Carbon drawdown, we need to do it, and yet billions of tons of CO2 is not a commodity that people want. It's waste that needs to be disposed of. It's as if we have to build a sewage system and collect the sewage after it's been dispersed into the environment. Very difficult. So everybody knows this stuff. There are natural methods. You reforest, you do regenerative agriculture and hope to draw carbon into the soil at the same time you grow food. That would be a great thing if we could accomplish it. There's the seashores. There's kelp. There's growing. There's drawing carbon down into the ocean by seeding it so that algae bloom and then die and fall to the floor of the ocean. There is direct air capture machinery that vacuums CO2 out of the air, and then you have it to dispose of as you will. Or in some cases, it's proposed that CO2 that's brought down gets broken down and becomes useful products, carbon-based products of one kind or another, as
Mhm.
liquid fuel, as construction materials, etc. But when you're talking about billions of tons, it's much, much more than we would need for civilization's purposes. So it's a weird chore in that it is not a product that people want. It is not a great investment opportunity. It's like a sewage plant. It should be a public good. It should be paid for by the public, perhaps. And of course, sewage plants are built by private companies who then make a profit from them, from the being paid by the public. So there are analogies to this carbon drawdown. But really, we're talking about so much of it that the natural means are probably best.
Mhm.
Reforestation, regenerative agriculture, the ocean methods, those get less and less nature-based and more kind of chemical and bizarre, but they are biological. The biological in this case will be faster than the mechanical and scale better. So, I mean, I'm going to quit there because I believe that this is probably pretty well known to everybody on the call already.
So let's talk about the economic system behind that, right? So you mentioned it should be governmentally based. In Institute for the Future, you have something called the Carboni, which is a carbon token or coin.
Yeah.
In real life, Delton Chen is building something kind of similar to that with the global carbon reward, I believe it's called. What are your thoughts on how that is going? because the economic incentive seems to be one of the biggest challenges here, right? It's not, we're currently missing the economic incentives for enough people to draw down enough carbon in some ways.
Well, yeah, but let's separate this out. The incentive is the survival of civilization and avoiding a mass extinction event and a crash of civilization.
I'm
So
with you
that,
on that front. Yeah. But it
but
doesn't seem that the rest of the world is.
how do we no, but how do we pay for it? I'm just trying to
Yeah.
separate out.
Yeah.
There's incentive as an economic term, and there's incentive as a human motivational term. And I'm just maybe hair splitting here, but I want to get the words right. How do we pay for it is the question. The Ministry for the Future, the solution in that is a literary symbol standing for quantitative easing. And the Chen paper was very important to me, Delton Chen's paper and his global carbon reward. But his is just one specific methodology for a much more general principle. And the Network for Greening the Financial System, which is an association of about 90 central banks. And of course, the US has withdrawn from it during the Trump times, but presumably will come back later. That network of all the central banks, like 90 of them, including all the biggies, is discussing quantitative easing. Greening the financial system in their terms means using all kinds of financial instruments to push civilization and capital. I must say, private investment capital, which, well, that's redundant. Capital is to be invested. It has to be. Capital needs to be um, channelized, induced, forced, tempted to uh, send its money into this project. And then quantitative easing is the invention of new money by the central banks themselves. We're talking about fiat money here, not a kind of crypto coin, which I think Dalton Chen is too absorbed in.
Mm-hmm.
You could just say carbon quantitative easing. You could make up the central banks of the world could together make up $1 trillion a year that would be dispersed to green projects everywhere, to decarbonization everywhere. That would be certainly enough to get us off to a great start. So carbon quantitative easing by the central banks, and then really the job of current investment capital and of philanthropies and even governments with the budgets that they have, in other words, legislated money, like the Biden IRA bill, which was a significant world achievement before it was attacked. These all these funds together will be needed. It's an expensive project to build a sewage system after the sewage has been released. And when we're talking about billions of tons that is spread as the gas in the atmosphere at a very slight, well, at 420 parts per million. So the complications are severe, and paying for it is indeed a big question. I tried to treat it in the Ministry for the Future as a sort of literary symbol, in other words, a single method. But what I'm saying is the Network for Greening the Financial System, they have a white paper on this that describes about 9 or 10 ways. Maybe altogether they add up to the carbon coin. Maybe they're all versions of the carbon coin, as I put it in my book. So I would not plump for any one method. I would just say we need quantitative easing from the central banks devoted to green causes and leave the finance people to play their games of how to administer it, finesse it, make money off of it, etc. They will enjoy that. They will be invested in the process of doing it by being the ones to invent the details of it. So prescribing to the central banks and the financial world and to Wall Street of you should do this, as the Chen paper does, is I think a mistake. Better to set the goals and let them find the methods.
So I'm going to open us up to questions in about 8 minutes. So if you have a question, feel free to drop it in the chat. In the meantime, I want to talk about another solution. One of the things that we see at FIRE and SNS a lot is there are a lot of technical solutions out there. A lot of the right technical solutions are missing the funding that they need to succeed or to scale. And or there is a slowness to policy making and people that is really the biggest barrier to climate solutions. And I'm wondering if you could talk about each of those two parts of this challenge that we are globally facing. Do you see a, a path forward in or solutions when it comes to shifting people's perspectives? For example, in the Ministry for the Future, you bring up this idea of a global religion defined by Earth, right? An Earth-driven global religion. Are there people technologies that we're not thinking about that we should be considering as we think about our future together?
Well, this would take a lot more than 8 minutes, and I do want to talk about ice preservation also before we get going into the Q&A. So I'll just say this. We're in a vicious fight over political fight over control of how we respond to climate change. And so it's shocking to imagine that in the year 2025 there are denialists in charge of the U.S. government because they themselves know that climate change is real and is happening, and so they end up being the equivalent of a death cult. In other words, the Götterdämmerung. If I have to die, I'm going to kill the world too. And this kind of narcissism driving one of the major political parties on the biggest economy on earth is scary and dangerous. So that political fight is the framing our current moment, and all the good things that we suggest have to be put out as discursive weapons in a fight. And the case has to be made using all the tools of rhetoric and persuasion that to everybody who will listen, that this reality doesn't go away when you pretend. When you assert a fantasy, reality still bites. That's the definition of reality. So it could be April 1945 in Berlin before reality bites, but it bites in the end. So the sooner we forestall this fantasy and defeat it politically, the better off we're going to be, the less likely we're going to end up in Berlin 1945. So it's important to realize that the stakes are really high here and we're in a fight. But before we get to the Q&A, I want to describe one project because this is sometimes called geoengineering, but it's more interesting than that. And geoengineering itself needs to be destranded into each one of the methods that is being discussed. So you reflecting sunlight back into space and increasing the albedo of the planet, that's the most famous geoengineering. But drawing carbon down into the ocean by seeding it, that also is called geoengineering. These very different methodologies that all get bundled together as geoengineering obscures the topic to the point of making a knee-jerk reaction, oh, I'm against geoengineering, a completely useless response. And so one job for people who are interested in this is to destrand all these methods and discuss them one at a time for their costs, benefits, dangers, and advantages. Now, one of them is what Vint Cerf calls an overshoot problem. Even if we were to decarbonize rapidly, which is quite a hypothetical right now, we would still be in trouble for sea level rise because the West Antarctic ice sheet is and Greenland are likely to, but especially West Antarctic ice sheet because it rests on ground that is below sea level and is therefore very unstable. And Greenland is not the same and is a smaller problem. But if the West Antarctic ice sheet breaks up and quickly melts, sea level rises 4 or 5 meters, and civilization is then hammered in a way that it might not be able to recover from, and we have social breakdown and a war of all against all. So what can one do? Well, what's interesting is that the big ice streams in West Antarctica that are moving quickly into the sea, one of them came to a sudden halt about 150 years ago. It was called Ice Stream C, and A and B are still moving very quickly, but C stalled and stopped about 140 years ago. And the glaciologists noticing that had to ask why. That ice stream is now called the Cam ice stream after Bernard Cam, Kamb. The Cam ice stream came to a halt. And the glaciologists who discovered that said it's probably because the water underneath that ice stream was shifted over into another basin. And the ice stream therefore thumped back down onto the rock and slowed back down. Could humans do that by pumping the water out from under the ice? In some cases, that water is only a couple millimeters thick between ice and rock. In other cases, there are under ice watersheds where the water has carved stream beds in the till of the bed and in the ice lying over it, so that you have some river systems. But these can easily be broken and changed in direction. So this ice preservation project, which is chaired by Vintsurf, but is run in a practical sense by a bunch of glaciologists, some of them at Stanford, I've been following their work because their work is somewhat inspired by some of them reading The Ministry for the Future. And the guy I got the idea from for the Ministry for the Future, Slavek Tulicek, is now the head glaciologist of ice preservation. They want to do some experiments in the north, in the Arctic, Alaska, Iceland, Svalbard, even Greenland, because it's so hard to do experiments down in Antarctica in terms of expense and distance. But what they want to find out is, where should we pull the water from underneath these ice streams, and what happens when you do. And with that data, experimental results and modeling, they propose to go down to Antarctica and try to slow down the fastest ice streams in the West Antarctic ice sheet. It's something rather huge that humans could still possibly do with our own physical powers. We pump through the ice all the time. I mean, we drill through it. It's melting, really, and we pump water up. So this is not any kind of radical or new technology required. It's an application of engineering to a new problem, and I'm therefore interested. And I myself, and with some others, made a presentation to this project to groups in the Pentagon. And so the U.S. Navy, the Coast Guard, people interested in sea level and in national defense in its largest sense. Also, logistically, you would need the U.S. Navy if you're really going to do this, because one aircraft carrier is a bigger town than McMurdo. And with a lot more aircraft as well. And West Antarctica is a working human space. So this possibly practical project is something that I'm quite interested in and am following. And it's a thread that leads into the larger discussion of climate interventions more generally, because it's dealing with a secondary overhang problem that is going to be staring us in the face no matter what we do with the rest of the climate issue. So with that, I'm done. I did want to describe this because I think that the ice preservation idea is somewhat new, maybe even to people in this crowd. And so I wanted to share it because I find it very interesting.
It's fascinating. Do you think, how do we get there? What's missing? What's needed to make it happen?
Well, ice preservation is trying to do the experiments in the north on small glaciers to give some data to the modelers. And there's a modeling group now at Caltech called ARET. So there are more than one teams focused on this problem, and the Caltech group is modeling experts and mathematicians. Ice preservation that I'm associated with directly is concerned with glaciology in the field to give data to the modelers. And then after that, it would need more than philanthropy or investment. It would need national government icebreakers, and I think a nuclear aircraft carrier, possibly even nuclear subs down underneath. But those could be robotic, small robotic submersibles going right on up underneath the West Antarctic ice sheet are not at all impossible technologically. So the main thing would be a buy-in from the national governments to say, and the Antarctic Treaty is involved here. So the Antarctic Treaty nations would have to decide as a group, yes, we'll agree. Let's try this. Let's send an aircraft carrier or two down there, an icebreaker or two down there, to Thwaites, to the Ross Sea area and the Amundsen Sea area, and settle in and give it a 5-year try and see if we can slow these ice sheets down. And if we can, then that's a maintenance thing that might last a century or more. It is a small expense compared to sea level rising 5 meters, and I know all of you can understand that immediately.
So we have a lot of questions. I guess at this point we will be let's turn off the recording so that you can answer these questions.